All right, we are starting Unit 7, and we're talking about moles. So in this unit, we're talking about moles, and it's one of the most important concepts in order to be successful in our chemistry class. A mole is a pretty common word. It could refer to a number of everyday things. It could be an animal. It could be something on your skin. Maybe you're thinking of a spy movie, undercover agent. In chemistry, a mole is not any one of these three things. A mole is the SI unit that describes the amount of a substance. A mole relates to the amount of a substance in several different ways. First off, it could be by number of particles. For instance, atoms. We've been talking a lot about atoms up to this point in the course, getting to know what they're made of, how they act, but we haven't really talked about quantity. As far as atoms go, they're really small, and there's a lot of them, even in a small sample of a chemical. So we could talk about the amount of a substance in terms of how many atoms do I have? Or we could talk about it in terms of how many molecules of something do I have? It could be in terms of mass. Mass is more helpful because it's really hard to count out 10 million atoms. For one thing, it's a very small piece of matter. We can barely see it with the most powerful microscopes. And two, counting to numbers like 10 million takes a really long time. So mass is a more useful measure. If I know that each atom has a certain mass, then I can measure the mass of a sample on a balance and from there figure out how much substance we have. It could also be in terms of the volume of a gas. So if you think about a balloon, you blow it up, you are putting gases into it. Then you tie it off, and the gas is pretty much stuck inside the balloon. The volume of the gas corresponds to how much gas is in there. So all of these three things can relate to how much matter is present in a particular sample of a chemical. So the first thing is the mole and the number of particles. So a representative particle is the smallest unit of an element or a compound that maintains its properties. The representative particle of a covalent compound is the molecule. The representative particle of an ionic compound is the formula unit. The formula unit is a ratio. It's the lowest whole number ratio of the ions. Remember our 1 grain of salt? It had 6 times 10 to the 17th sodium ions and 6 times 10 to the 17th chloride ions. And that'd be difficult to write as a formula, but that's a 1-to-1 ratio, and so we reduce it and it became NaCl, just one of each. Other types, we have atoms are representative particles, ions are representative particles. These are the ones you'll typically see in this course. So a mole is a definite quantity, very similar to the way that a dozen represents 12. A mole is a very specific number. However, a mole is a really large number. 1 mole contains this number of representative particles. To keep things a little more simple, we round it to 3 significant figures, and we convert to scientific notation. And so we end up with 6.02 times 10 to the 23rd. It's important to remember that this is just a number, and the mole is a quantity that relates this number with better units. Remember, just like this, 1 dozen equals 12 something items. 1 mole is 6.02 times 10 to the 23rd of whatever particle we're talking about. So our number, 6.02 times 10 to the 23rd power. This is the number of particles in 1 mole. And it has a name. This number is a constant, and its name is Avogadro's number. So this number is a helpful mathematical relationship that we can use in this course. And as a note, in this unit, you're going to need a calculator every day. You can just assume that a calculator is needed. So let's look at some conversion factors here. If we have a number of representative particles, and we want to take this really big number and change it to moles, which would be a more manageable number. This goes back to our dimensional analysis from Unit 2. The number that I want goes on top, or the units that I want go on top. The units that I have will go on bottom, and that would be atoms, molecules, or etc., whatever it is we're looking at. And the numbers here, for every 1 mole, we have 6.02 times 10 to the 23rd of whatever the particle is. And so you can use this relationship. So let's say that I tell you a number of carbon atoms. Let's say that I have a sample and I tell you this sample has 6.02 times 10 to the 23rd carbon atoms. That's a pretty specific number. Our dimensional analysis strategy in this class says make this a fraction over the number 1. The units we have will go on the bottom of the next conversion, and that's carbon atoms. And the unit that we want in our answer will go on top, and that's moles. And so from here, we know that in 1 mole, there are 6.02 times 10 to the 23rd carbon atoms. And this is something that we would put into our calculator, and this one is actually 1.00 moles of carbon. The abbreviation for mole, MOL. This is the accepted abbreviation. That's something that we talked about back in the first unit. Another possibility, if I said we have a sample with 1.81 times 10 to the 24th CH4 molecules. If you were to Google the name of this, it would tell you it's methane. That's the most common word for it. And under our naming system from Unit 6, this is carbon tetrahydride. And so the same idea. We have molecules, and I want to know what this is in terms of moles. So moles are on top. That's the unit I want. Molecules on bottom. That's the unit I want to get rid of. And so we know that 1 mole is 6.02 times 10 to the 23rd molecules. And we would put this in the calculator and get 3.01 moles of CH4. Now back in Unit 2, we introduced the idea of significant figures. And we worked with them for a while and with the dimensional analysis, and then we left it alone. Now we're coming back to significant figures. If you look at these numbers, for instance, 1.81 times 10 to the 24th, this number has 1, 2, 3 significant figures. And remember, this 10 to the 24th doesn't count. And then over here we have 1, 2, the non-zeros count, and the 0 between them is also significant. And so if you need a refresher on significant figures, you're going to need to go back to Unit 2, or you can talk to me sometime in class or online. One more, let's say we had 3.18 times 10 to the 23rd NH4 plus ions. That is ammonium ions. Now I want to know how many moles of ions do I have. So here's moles. And here's ions. Ions are on bottom so that they cancel top and bottom. So we know that in 1 mole there is a very specific number of particles, ions in this case. And we put this in our calculator and we get 0.528, and that's moles of NH4 plus. Now this is something that's a possibility. I have less than 1 mole, and that's fine. You can have half a dozen, so why can't you have half a mole? So this is perfectly fine. It could be an answer less than 1. 0.528 moles is a reasonable answer. There are other times where you will receive a number that is already in moles, and we're looking for how many particles are actually there. And so when you start with moles, you want to have moles on the bottom of your conversion factor. And then on top, it's atoms, ions, whatever the case is, and it needs to be specific. So for every 1 mole, there are 6.02 times 10 to the 23rd of whatever particle it is. So if we were in the lab and we found 2.50 moles of aluminum, and we want to know how many atoms of aluminum are here. Aluminum, Al, is just an atom, so we put this over 1. So 1 mole is a very specific number of aluminum atoms. And so we're multiplying these two numbers together, and we get 1.51 times 10 to the 24th, and that is atoms of aluminum. You'll notice I'm in the habit of labeling my atom or my compound every time. In future units, we're dealing with multiple chemicals. They're in a chemical reaction. So it's a good habit to label right now what chemical am I talking about? What element? What molecule? Let's say we have 3.65 moles of sodium chloride. So 3.65 moles, and we want to know, we're looking for formula units because this is an ionic compound. So in 1 mole, there is 6.02 times 10 to the 23rd formula units. So we put this in the calculator, we are multiplying these two numbers together, and we find 2.20 times 10 to the 24th, and that is formula units of NaCl. Here's another possibility. We've got 0.912 moles of carbon dioxide. Here again, we have less than 1 mole, and that's fine. If you only have 9 eggs, you've got 0.75 dozen. So it doesn't matter that it's less than 1 mole. It's just the way the numbers work out. So 1 mole of carbon dioxide has 6.02 times 10 to the 23rd molecules of CO2. And we multiply these numbers together and we get a number. This is how many molecules of CO2 we have in this particular sample. One last note in this video, make sure that you include appropriate units. So appropriate units. A representative particle is not an acceptable unit. A representative particle is just a basic idea of there is something more specific. So if your unit will be a mole or moles, it's just MOL. If it's an atom, if it's atoms, just call it an atom. I don't really need to see the S on the end of it. It'll at least save us 1 letter. Molecule, molecules. This one, there's really not a good abbreviation. We just have to say molecule. M is meters, MO is something, MOL is moles, MOLE is moles. So you're looking at a pretty long abbreviation even if we did. Formula units, if you need to abbreviate, this is the appropriate abbreviation, form unit. So let's look at what these are not. So molecules is not M, MO, MOL, MOLE, etc. Formula unit, it's not the initials. That's going to end up in the trash.